Hi everyone, this is Mr. Cole, and today we'll be starting our new chapter of Chapter 9, Ratio and Rate. So in this video, we're covering ratio, which is a recap of our primary school syllabus. So in this lesson, we're going to express quantities as a ratio and how to convert equivalent ratios, and we'll be talking about algebra in ratio. So what is ratio? So ratio is used to compare two or more quantities of the same kind. So same kind is very important because you need to make sure that they are in the same units. And normally it's expressed in the form of A is to B, alright? Where A and B are purely positive numbers. For example, 2 is to 3, 5 is to 7, 21 is to 4. Okay? And they can be expressed in equivalent ratios by multiplying and dividing all parts by the same number. Alright? So for example, 6 is to 9, when we convert it into 2 is to 3, what actually we are doing is we are dividing both sides by 3. Okay? Now, in this case, you may recognize this as the simplest form because 2 and 3, there are no other common factors. So this is what we call our simplest ratio. And then if you want to express in higher numbers, we can also multiply both sides, both parts by the same number, in this case multiply by 2, and we get 4 is to 6. So all of these are acceptable ratios, but then in our final answer for our questions, we always express it in the simplest form. Okay? Now let's try out some questions. A recipe uses 15 cups of flour and 25 cups of sugar. Express the ratio of flour to sugar in its simplest form. Okay, so we got 15 and 25. So our flour is to sugar is simply 15 is to 25. However, is this our simplest form? Most of you have realized that 50 and 25 definitely have some common factors. In this case, it's a common factor of 5. So we divide both sides by 5, and then we'll get 3 is to 5. And this is our simplest form. Next, we have a ratio of 300 seconds to 1.5 minutes. So remember, back in our explanation of ratio, we must be comparing quantities of the same kind. So one is in seconds, one is in minutes. So let's convert minutes into seconds. What we do is take 1.5 multiply by 60 to get number of seconds, which gives us 90 seconds. Alright, so now we have 300 seconds is to 90 seconds. We simplify it. First thing, we divide by 10. Alright, divide by 10, we get 30 is to 9. 30 into 9, our next common factor we can take out is 3. So we divide by 3. So we get 10 is to 3. Is there any more common factors to take out? 10 and 3, no other common factors. So this is our final answer. This is our simplest ratio. Is that clear, everyone? Okay, great. Now let's go on to our next question. Simplify the following ratio. 2 2/3 is to 1 over 6. Okay, so normally for this kind of fractional ratio, what I like to do is express it in improper fraction first. So I express it in improper fraction, what I get is 2 times 3, 6, plus 2, 8. So 8 over 3 is to 1 over 6. So the very first thing is, simplest ratio always must be in whole numbers. If it's fractional, it's in fraction, it's not the simplest form. Okay, so we want to get rid of the denominator into whole number. So we have 3 and 6 over here. We just simply multiply by 6 on both sides to remove the denominator entirely. So 8 over 3 multiplied by 6, in our calculator we will get 16. And the right side we simply just get 1. Just nice. This is our simplest ratio because 1 cannot be further divided any smaller. So this is our final answer. Is that clear, everyone? So repeat again. First step, convert into improper fraction. Make it easier to multiply the numbers, and then we multiply by the denominators. In this case, 3 is a factor of 6, So we just multiply by the bigger number 6, and then we can remove both denominators. But in the event where both denominators are different, as in one is not a factor of the other, then what you can do is just multiply by the denominators of both of them, and then afterwards simplify further if needed. Okay, question 4. Alright, so this is a question that's adapted from the textbook on page 40, where we have to use algebra to find unknowns in ratios. So we have these two ratios given the question. 3a is to 7 is equivalent to a ratio of 8 is to 5. Now, how do we find out this unknown ratio? Alright, unknown algebra in the ratio. So, notice that when we talk about ratios, alright, the left side is associated with the left side, the right side is associated with the right side. Now, to make the ratios truly equivalent, when we compare the numbers, we must make the side with the known value to be the same. After we make the side with the known value to be the same, then the other part with the unknown value should be equivalent to the same. And that's how we find our unknown value. Okay? So our job is to make 7 and 5 the same value. And how do we do it? So you remember back in our primary school days, we just multiply by each other. So on the left side, what we're going to do is we're going to multiply by 5 on both sides. Okay, that will give us 15a is to 35. And then on the other side, we're going to multiply by 7. Okay, multiply by 7. 8 times 7, 42. 5 times 7, 35. Now we notice that both right parts are the same. And because they are the same, the left sides must also be the same. Okay? Let me just check. 7, 3, 8, that's fine. Okay, correct. So then 15a is simply equals to 42. And then a will just be 42 divided by 15. And that gives us an answer of 2.8. Or we can write it as a improper version 2/4/5. Or we have 14/5. Either one is fine. Is it okay? Now let's look at the next question. Very simple, same steps as well. So we have 5 is to b, and 5 squared equals to 4 squared. Some of you may think, on the right side, I have square and square. Does it mean to make it the same, I simply just square both sides and this one become b squared, and then b just equals to 4? Correct? Is this the case? Take note that when we are doing ratio manipulation, to maintain equivalent ratio, we can only multiply or divide by the same number. If we square the entire ratio, this is no longer an equivalent ratio. Okay? So that is a common misconception that you should not do. Instead, what you should do is express this out as in we simplify the power. So then this will give us 5, let me just write it in black. 5 is to b equals to 25 is to 16. So we don't confuse ourselves with the power now. Then we think, we have 5 on the left part, 25 on the left part. How do we convert 5 into 25? We simply just multiply by 5. And that will give us 25 is to 5b equals to 25 is to 16. Now, when both of the left sides are the same, we can finally compare our right parts. Alright, let's compare these two parts. So then we have expression 5b equals to 16. b would just be 16/5 or 3.2. Is that okay? Hope everyone is clear with that. Let's go on to expressing percentage of a quantity. So finding 40% of 120 centimeters. Okay, so let's move on to the next part, ratios involving three quantities. So a bag contains red, blue, and green marbles. The ratio of the red to blue marbles is 3:5, and the ratio of the blue to green marbles is 10:7. Find the ratio of red is to blue is to green marbles. This is a typical primary school question that you may have seen before. So if our red is to blue is 3:5, and our blue is to green is 10:7. How do we express all three quantities in a same ratio? So notice the common term is actually the blue one, 5 and 10. So one is 5 parts, 5 units, one is 10 units. So to make them join together, we simply express the common terms as the same number of units. So then we just need to multiply by 2 on both sides of the red is to blue ratio, and we get 6:10. Now we notice that we have the same units for the blue parts of the ratios. So then we now can join them together to get red is to blue is to green, a ratio of 6:10:7. And notice that we can no longer divide this any further, simplify any further, because 7 is a prime number, and this is our simplest ratio. Okay, if not, then this is the end of part 1, and then see you in the next video.